We are told a curve C has equation y equals x squared minus 2x minus 24 root x, where x is greater than 0. Part A is asking us to find dy by dx first, and then part 2 is saying find d squared y by dx squared. So the first thing I want to do is rewrite y in terms of a way which will make it easier to differentiate. So we've got x squared minus 2x and then minus 24x to the half, like that. Okay, so to find dy by dx, okay, all we need to do is, for any term which is y equals ax to the n, dy by dx equals an x to the n minus 1. All right then. So dy by dx equals 2x minus 2 minus 12x to the minus half. Okay. So moving on, now let's do d squared y by dx squared. So d squared y by dx squared equals, so to find d squared y by dx squared, what we need to do is we need to differentiate dy by dx with respect to x. Okay, so to do this, we need to just differentiate each of our terms in dy by dx with respect to x. So the derivative of 2x with respect to x is 2. The derivative of minus 2 with respect to x is 0, so we leave it. And then the derivative of minus 12x to the minus a half is positive 6x to the minus 3 over 2. There are 3 marks available for this question. The first 2 marks come from correctly differentiating y to get dy by dx. And then your third mark comes from correctly differentiating dy by dx to get d squared y by dx squared. Part B is asking us to verify that C has a stationary point when x equals 4. So a stationary point is when dy by dx at a certain x value equals 0. So what we need to do is we need to test whether dy by dx at x equals 4 is 0. So let's do that. Dy by dx at x equals 4 equals, so now let's plug in our x values. So we have 2 times 4 minus 2 minus 12 and then 4 to the minus 1 over 2. So let's start simplifying. So we've got 8 minus 2 minus, so 12 times 4 to the minus a half. 4 to the minus a half is the same as 1 over root 4, which is 1 over 2. So minus 12 times 1 over 2 gets us minus 6. And this, in turn, equals 0. Good. So now we just need to finish this by giving a concluding statement. So we're going to say something along the lines of dy by dx at x equals 4 equals 0. Hence, a stationary point at x equals 4. Okay. This question is worth 2 marks. All right. Your first mark comes from being aware that you need to substitute x equals 4 into your expression for dy by dx. So this line of working here will get you your first mark. Your second mark will come from showing that dy by dx equals 0, and then again using it in your argument to say hence a stationary point at x equals 4. Now bear in mind that saying dy by dx at x equals 4 equals 0 and hence a stationary point at x equals 4 are both required to get the second mark for this question. So if you only have one of them, you don't get any credit. So part C has asked us to determine the nature of the stationary point and give a reason for our answer. So to determine the nature of a stationary point, there is sort of one key rule you go by. If d squared y by dx squared at a certain x value, so x equals a, is greater than 0, this means the stationary point is a minimum. And if d squared y by dx squared at some other x value, so x equals b, say, is less than 0, then this is a maximum stationary point. So all we need to do is plug in x equals 4 into our expression for the second derivative and then see which case it meets. So we can say d squared y by dx squared at x equals 4 equals, so 2 plus 6 times 4 to the minus 3 over 2. So this equals 2 plus 6 over 8, which equals 2.75. Okay, so now here's where we need to be careful. We need to say that d squared y by dx squared at x equals 4 equals 2.75, which is greater than 0. Hence, stationary point is a... So we said if it is greater than 0, it's a minimum. So, hence, stationary point is a minimum. Okay, so this question itself is worth 2 marks. You get your first mark for being aware that you need to substitute x equals 4 into your expression for d squared y by dx squared. So that would be it. Your second mark comes from stating both that d squared y by dx squared at x equals 4 is 2.75, which is greater than 0. So this whole sort of section here, chunk, gets you 1 mark. Well, not 1 mark, 1 point, and then hence the stationary point is a minimum, is the next point. So you need both of these points to get the second mark for the question.